Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia for the hyperbolic secant function, SECH. The hyperbolic secant function takes an input argument, assumed to be in radians, and outputs the hyperbolic secant of the corresponding angle. The hyperbolic secant is the same as 1 divided by the hyperbolic cosine, which means that we can get some information about this graph by looking at the hyperbolic cosine, which is a kind of an upside down, approaches 1 when the input is 0 and then explodes as it goes out to infinity. Of course, 1 divided by that is approaching 1 at 0, and then drops off to 0 as the hyperbolic cosine goes to infinity. 1 divided by infinity approaches 0. I've shown this by taking an input value in degrees across a range of degrees, I think in degrees, and then in column B, converting to radians and taking the hyperbolic secant. So what we can see is that for a number even as small as 100, or a value of 100 radians, the output of this function already becomes very, 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 very small. 7.4 times 10 to the negative 44 is a lot of zeros after the decimal point before you see a number. I think that it'll take very, very large input values. No, it won't. What will it take? Let's see. Well, it looks like the largest value that this can actually take is what I prepped in here already. It's about 2. After that, this value just explodes. I think about 2.8 or 10 to the power of 2.8 or 600 is getting really, really close to the boundaries of the smallest number that Excel can represent that is just not 0. Yeah, after that, it's just going to be 0 for a while. And then somewhere here, I thought it was going to break and just throw a numerical error, but no. It's well defined all the way out to 1 times 10 to the 308. For very, very small values, this just approaches 1. For very, very small positive values and negative values, because this is an even function, so it's symmetrical about the y-axis at x equals 0. It approaches positive 1 from both the negative infinity side and the positive infinity side. Well, that's basically the hyperbolic secant of x. Some related functions are the other inverse hyperbolic trigonometric functions, like the cosecant hyperbolic or the cotangent hyperbolic. The inverse of this is the hyperbolic cosine, and you could always go and look at the normal secant, which is defined by a circle instead of being defined by a hyperbola. This concludes the video encyclopedia entry for the hyperbolic secant function. Please take a moment to like, comment, and subscribe to the channel if you haven't already done so, and you want to see more content like this. Thanks for watching.